Now, photoelectric effect, it started during early 1900s. So, in 1900, so a person called Leonard, a physicist, so he experimentally demonstrated photoelectric effect. Okay, it was actually done during the time of Hertz. Okay, so what Leonard did was, so look at this. This is the experimental setup. See what we have. We have a glass tube. Okay, and it's vacuum. This is first thing. Now, see, we have an opening. Opening meaning there is a type of an opening which is coming and hitting the emitter part, and then we have a collector. Okay, so name itself suggests emitter emits the electrons, collector collects the electrons. Okay, now this collector can be maintained at different potentials with respect to emitter, meaning collector could be positive, emitter could be negative, or the other way also. Okay, either positive negative or negative positive. So collector potential can be varied. How it can be varied is because of the voltage what is given. Alright, now a microammeter is connected to the collector part, and then that is coming and that is connected to a voltage source. So this voltage source, this basically gives the potential. Okay, so potential meaning it gives the potential of collector with respect to emitter, either negative or positive, it depends. Alright, and we have a rheostat, basically a variable resistance, and we also have an voltmeter to measure the voltage. So this is the experimental setup. Now remember, there are certain important key points in this. One of them is the glass tube is vacuum and it is made up of quartz. Okay, and the incident radiation what we have, okay, which is coming and hitting the emitter, that can be varied, meaning the intensity of light can be varied by either taking this source close to the emitter or far away from the emitter. Alright, we can also change the frequency of the emitted radiation. Okay, so everything can be varied. Fine. So this is the experimental setup for the photoelectric effect. So what happens was, as the radiation hits the metal surface, electrons are emitted. Now usually what we do is the collector is kept at positive potential, emitter is kept at negative potential, because electrons has to be ejected, correct? Now if collector was positive, then it will attract the electrons. So no electrons will be lost. All the electrons will be attracted towards collector. If collector becomes negative and emitter becomes positive, then collector will start repelling electrons. But since because of the incident radiation, the electrons will gain energy, so they will go reach the collector part. Okay, so here what happens is, in both the cases, the electrons will reach the collector. Whereas if collector is held at positive potential, all the electrons will come, none of them will be repelled. Okay, already electrons will be lost because of high energy. So if collector was kept at negative potential, more number of electrons will be repelled, correct? So how the experiment goes is, the radiation is incidented on it, on the metal surface, and the collector is kept at positive potential. The emitter emits the electron and the collector will collect. Now how much ever current is collected, that is shown in the microammeter which is connected to the collector part. Okay, so this is how the experiment goes. Now whenever an experiment happens, there are certain experimental observations, correct? So here also there are certain experimental observations which has to be noted. Okay, so what this experimental observation tells us, how the photoelectric current or the photocurrent varies with different parameters. So that you'll be learning in the next video.